Hey, what's up folks? Welcome back to another 3D Hangouts. My name is Noah Ruiz. I'm a designer here at Adafruit. Joining me every week is my brother Pedro.
Good morning everybody, I'm Pedro's Creative Tech here at Adafruit. Every week we're here to share 3D printed projects featuring electronics from Adafruit.
That's right, this is a show we combine 3D printing and DIY electronics to make inspirational projects like these. Hello everybody, we're hanging out in the Discord chat room. If folks are watching live during the show, you can ask us questions and what else can we do?
Post links,
say hello, do some banter. All that good stuff can happen in the Discord chat room. You can get an invite link to that by heading over to discord.gg/Adafruit. I want to take a moment to welcome everybody watching us live on the show.
Good morning, good evening, good afternoon, good night to everybody hanging out all around the world. We got Blitz City DIY,
Liz, good morning.
Andy Calloway, Rawson,
Andy.
Jim Henderson,
Good morning, Jim.
Vince, all hanging out in the Discord.
Yay.
Morning everybody in the YouTube chats, on Twitch, on LinkedIn, on Periscope.
All of the places.
And I think Facebook just went down. Oh, no, there. Good morning, everybody hanging out. Make sure to post your questions. We'll be posting all of the links to everything we'll be talking about. Good morning, George.
Good morning.
Let's go ahead and run through all of the housekeeping stuff. We got a jam-packed show again.
We do, so we're going to try to run through this quickly. Adafruit.com/free is where you can find all the deals that are going on in Adafruit. Right now, we still have 100 days of masking up, so any order that's over $1, you get a free black surgical mask. For orders that are $99 or more, you get the black surgical mask and a free Perma Proto half-size breadboard. For orders that are $149 or more, you get the Perma Proto, the black surgical mask, and a randomly chosen STEM QT breakout board. And if you are registered with Adafruit with an account, we make sure that you don't get the same one twice. For orders that are $200 or more, you get the randomly chosen STEM QT board, Perma Proto, black surgical mask, and free UPS ground shipping for continental US only. Then for orders that are $299 or more, you get the free continental shipping, STEM QT, randomly chosen, Perma Proto half-size breadboard, black surgical mask, and a Circuit Playground Express.
Yay.
You can go to adafruit.com/free to find out all the details that I have just told you. If you go to jobs.adafruit.com, you can find out all the different jobs that are available. If you're an employer looking to hire some makers with maker skills, you can post up your opportunities for free. And folks that are makers and want to make their profile, y'all can do it for free as well. So check that out at jobs.adafruit.com. Every Monday we have a CircuitPython meeting, and normally it happens on Mondays at 2 p.m. Eastern Time. This is a great opportunity for folks to come in from the community and listen in on the happenings in CircuitPython. The core devs and the community all come together and chat it out. There may or may not be Blink a Cake.
Very soon. Very soon.
Very soon we'll all eat Blinka.
Mm-hmm. Head on over to adafruitdaily.com to check out your daily dose of Adafruit. We have a bunch of different newsletters there. You can subscribe to everything from 3D printing, wearables, maker business,
Python
IoT,
hardware, IoT
Python
monthly.
Yep.
Yeah, lots of great ones. So check that out. If you want to subscribe to that, you got to do it manually because Adafruit does not automatically subscribe you. And then for once a week newsletter, this is called the new newsletter. It goes with Lamar's jingle that she does weekly on the new product videos. This is focused on products, so you can check this one out by heading over to adafruit.com/newsletter. Jingles sold separately. All right, I think that's the housekeeping stuff, right? What do I jump into next?
Let's go ahead and jump into this week's project.
Right. This week we are welcoming home Terrako.
We're not prototyping this, it's complete.
Oh,
it is this week's project.
That was the wrong thing. This one. I rearranged the stuff. We need to update this. Look at those old MakerBots back there.
Let's go ahead. Let's go ahead and jump into this week's project. It is the super cute Terrako from Zelda, not Breath of the Wild, Age of Calamity.
Breath of Calamity. Age of
This
Calamity.
is Terrako, which I didn't know that's what his name was until I finished building him.
Don't tell him that.
So it's super cute, autonomous little robot. There's magnets on the inside, so it is a shoulder companion bot. And this is all coded by Philip Burgess. It has a really nice randomization code, so he turns around all randomly. There's all these really cool code that we'll take a look at that generates all of the colors and what he's actually doing. All 3D printed. The legs are able to support his body upright, and there's also these magnets on the bottom used for the little metal backing that you can attach to your shoulder. You also have the option to sort of make like a little metal piece that you can attach to yourself and have it be a little companion bot. Strong little neodymium magnets that are on the bottom here. It's part of our pin backing little product we have for a bunch of the boards like the Circuit Playground Express. You can make like a badge from that. Super strong and they have a hold that is good enough for this nice little lightweight robot.
I'd love to see if he sticks to the fridge. That would be really cool to see him on the fridge.
We have not tested that. So all painted, you could dual extrude it. You have access to all of the history and the timeline for the Fusion 360 files for this. These nice little legs that you can position, and I think we'll go into the inside of it when we go over the Learn Guide. And this is one of those projects where Lamar wanted to sort of do an upgrade suggestion on some of the robots that have been posted in the community. A lot of the shoulder companion robot people like Jay or Alex Glow from the Hackster.io love making these, and Lamar wanted to make something that was themed to things that people like Zelda. And last week during one of our meetings, PT was talking to Phil Burgess on one of the upcoming projects and how it combines your passion, things that you're really interested and love, and combined it with Adafruit, making it into an actual project so we can, have some boards in there. And then the cherry on top for some projects like this is having your own kid being like, oh my God, cannot wait to be able to play with this little guy and have it as his own little companion bot. At first when we started the project, the companion bot thing was like, okay, that's pretty cool. But then as you start seeing it around, especially around Disney World, there's so many products that are companion shoulder plushes that everybody carries around.
Yeah, and that's sort of where this came from. This is a piece that came a part of one of the Banshee puppets that you can get from one of the Disney parks.
Yeah, so this is from Animal Kingdom. Okay. It is I should have brought him out. It's such a cool little puppet. There's so many actuators that help move his mouth and his eyes. There's sound effects.
Put him on your shoulder. Do a little demo here.
So
you hide it under your shirt.
Of course, this does work with the metal backing that is included with the magnets, these pins. You do get that. It does work with that, thankfully.
Yeah.
Because otherwise, it's like, oh no, you have to build that thing too. But
it
holds on like that.
Yeah, it's a good little solution. I don't know if you can purchase that separately, but maybe there's something you can either fashion it yourself or pick one up from.
So super cool that he just. The life, he comes to life with Phil's code.
For sure, he does. And the kiddo was walking around showing Terrako
he was
around his house.
So happy.
Hey, it's so good.
It's 7-year-old being just so stoked that they have that nice little companion bot. And Andy Calloway posted a image of what Terrako looks like when he's fully upgraded. Again, I didn't even know that he was a playable character.
He is once you beat the story mode. Spoilers.
Yeah.
But Terrako is quite the soldier.
I like how he has his own little guardian sword too.
Yeah, his little mini guardian sword.
Which we definitely got to print. We'll go over at Community Make. Somebody made a little tiny one that looks so adorable. It has all the lights in it. So cool. But what else can we say about it?
Very cute.
A very cute little project, especially if you have a little one. Or for yourself. I mean, I was super stoked when it came to life.
One of the goals was to keep it simple so that folks can actually build it. There were plans to making his little top move up and down and having sound effects, and that just adds more time, more complexity to it. So one of the goals was to, hey, let's keep it as simple as possible. What is the kind of minimal features that we need to make this thing look like Terraco? And this really does it. I really like that you painted the sides here. You could dual extrude, but painting it gives you that extra level of it's hand painted, and you get that nice kind of zen moment when you're painting him. Yeah, so it has this bronze look that is in the game, and you're able to just blotch the acrylic paint on there and sort of replicate the way that it looks like it's banged into place. Yeah. And it's sort of that rustic look that the whole Zelda theme has. It's ancient, but high tech. Bronzy, the retro future
type feel to it.
One of the byproducts of like making it simple is that I like that folks from the community who really like it can now add their features to it. Let's say they want to add magnets to the feet. You can like punch a hole through here in Tinkercad and like articulate this, or have strings run through it, and then you just add all the things that they want. Do you want sound effects? Well, there's your thing that you can contribute to it.
Yeah,
so keeping it simple not only helps us actually document it and release it in within a couple, maybe a month or two, but it gives the folks that really want to build it and add to it that opportunity. Like, hey, I want.
There is a little bit of room left in his body to be able to add more things. Vince is suggesting in the Discord chat that maybe adding a microphone to make him react to sound. Excellent idea. There's definitely room in there for that. And let's go ahead and jump into the Learn Guide for this. We launched this morning. It is quite a build. Nice little amount of steps that are required, but definitely worth it in the end.
Sure.
First, we'll start off with some of the overview on what this little guy is.
Let's look at the parts.
Mountability. Yeah, let's check out the parts.
Most of it's all in stock. This is awesome. We do have those magnetic pieces that you can get, and most of the cables and everything is in stock, so awesome. You can make a wish list and add all these things if you want, and if anything is out of stock, you can always sign up to be notified when they are back in stock. I think just the magnet right here is the only thing that's out of stock.
And you don't need that magnet. That's if you want to create your own sort of, I don't know what it's, the shoulder piece, like if you want to arrange it.
Piece, yeah.
But like we were saying before, the backing that it comes with works
this one?
really well.
This little pin here?
That's this,
this thing here.
the metal part.
Yeah, this is like for like a Circuit Playground Express. This little thing here, you can see that there's the two magnet pieces, and there you go. Okay, cool. All right, so those are the parts. The hero here, the brains. Yeah, the ItsyBitsy.
ItsyBitsy NRF 52840. We wanted to have some remote control in it, but time constraints and all that. Philby's working on some really cool ones for AdaBox and going forward. Yeah. So don't want to take too much of his time, since the main part of this was just to look, just to have everything fit inside there. So that could definitely be added. So keep that in mind. There are Bluetooth controls that you can add on there.
There is also demo code that you can use. Like the color picker is a really kind of well-known demo code that you can use if you want to change the color and stuff and try to implement it into this right here. So cool. So there's that extra added Bluetooth. That
One more part about the ItsyBitsy NRF. I will be updating that once the ItsyBitsy PR2040 RP
Raspberry Pi,
not GitHub.
Yeah. PR.
RP2040 ItsyBitsy. The QD Pi RP2040 was just released.
Yeah.
They won't work with that.
But this is a great little board. The NR52 has got a lot of RAM, and it's got like how many megabytes of SPI flash? I feel like 2 megabytes or so.
Oh.
Yeah. So it's a really good board. It's super. It's the smallest we can get, right? So one of the things that you need to add. Oh crap. The Lipo Backpack. So it's somewhere here.
Whoops.
There it is. There it is. The Lipo Backpack. This little guy is designed to work with. Originally the trinkets in the ItsyBitsy, kind of the original ItsyBitsy, but this also works with the newer style of the ItsyBitsys with the M0s, the M4s, and the NRF. So this little guy is going to make the USB port, allow it to recharge the LiPo battery. So for a little project like this, you definitely want to be able to recharge the battery over USB. And the little Lipo Backpack gives you that extra circuit to do that.
The other extra thing that it does is allow you to add a slide switch.
Yeah, it's got built-in pins for slide switch, so let's...
We'll look at the techniques that I use for cutting the trace a little bit later on, but yeah, you can see the slide switches right there, and the USB port is on the whole other side. Where do you go? There you go. Access to all of that, so you can charge and edit the CircuitPython code. It just loads like a USB drive.
I like when you pick him up, he gets mad and his eye turns red. And when
I know
you put him down, he goes blue.
It's so cool how you can interpret, like humans interpret like the random movement for this with actual sentient
Another example is like Gavin, your 7-year-old. He was so like, he was dead on sure that, hey, this thing is listening to me. When he talks, like he would turn to him.
We definitely got to add that microphone on there to have him react to sounds. That'd just be the icing on the cake.
Yeah, the super extreme version is like do some Raspberry Pi machine learning where you like hold up the finger too, and he goes boop boop like too.
That
gives you a little victory too. All right, anyway,
awesome.
we're daydreaming.
There's so many things that you can.
Yeah, but when you want to recharge, when you want to add recharging to your portable project, the Lipo Backpack is the way to do it. So all right, let's
I
head
will
over
add
to.
that. I'll add that on there. One
Yeah.
of the other things too, cables. I needed to make sure that this was easily you could easily assemble this or disassemble. I didn't want to thread wires through, solder it, and then I'm like completely stuck where I would have to unsolder the NeoPixel or the Servo. If when you're iterating on these projects, you're going through so many different printed body parts.
Historically, we've had like bigger connectors, and there's always a little. The connectors themselves are always kind of like the limiting, like how much space do I have?
Especially for the
little
Servo.
Project. Yeah,
it's relatively flat, but it's long,
long.
and then it's wide, and that that messes with
So,
how small you can make things.
Shout out to Leida. She's been on a tear, like getting these smaller connectors that are perfect for these type of components and projects, where they need to be as small as possible, and every millimeter counts. So these new Molex cables, definitely check those out. They come in different wire arrangements. So we have 3-pin, 4-pin, I think 5, right? Something like that. So you can check these out here and
I think it goes
pick up a couple of them because they are really nice connectors, so small. Another great project that this works in is the lightsabers. Every little piece of like every inch, it's too big. Every millimeter of clearance is critical, and these connectors are so small, and there's plenty of wires to connect, whether it's a Servo or a NeoPixel strip ring, what have you. Yeah, this is a great one. Again, they're Molex Pico Blade, cute name as well.
Trying to put all of the links in here as I'm talking.
Yeah,
it's always harder when it's my turn
because
for
I gotta run Wirecast and like tab switch. It's like I can't do that extra add-on.
So if you hear me pausing, it's because I'm posting links and all that to Twitters and everywhere.
Right. So cool. Highlighting some products here that we really like.
I think we already talked about the JST.
The battery, there's not much to tell about the battery.
So either a 420, I think, is the biggest battery just because of the body size. I designed everything around the Servo.
Right.
And of course, trying to make it lightweight so the magnets will hold on.
Did you try a 500? Does that fit?
I did. The horn gets in the way.
Okay, so don't get a 500.
So get a 420.
Again, don't get the 500. It's going to intersect with the horn. We will show you that in a second here. But that's the battery. It's the smallest, most capable battery right now. This is a really good one for like
suggested
all the high
by Lamar.
Yeah,
for Servos.
Good price. All right. That's about it for the products.
The only other thing is one screw for the Lipo Backpack. Yeah, you just need one screw. 2.5 by 5 millimeter long screw.
Right, for the backpack. Okay, yeah. Make sure it's metal, not plastic, because
yes, I did try that with the nylon ones that we have in stock, and
plastic
the sizing doesn't work out.
They're good. All right, let's go to circuit diagram. This one's just going to show you the wired connections. 3 wires from the Servo. They're going into what, VHI and A2. You can switch that out if you'd like. And then the NeoPixel Ring, this is this 12 or 16? I think it's the 16.
16.
Yeah, and this one plugs into D5 and VHI and ground. And yeah, check that out. You can reference this as you're wiring it all together. And then for accessibility purposes, we always try to write out all the wired connections for accessibility purposes. So you can check them out, and they're all.
There's an ADR.
ADR, or ADA. ADA. Yeah, one note about wiring diagrams, we use the open software called Fritzing, and so if you want to create your own wiring diagrams, you can download Fritzing for like $10 or something, and you can get the Adafruit library of all the parts, so the ItsyBitsys and just about everything gets made for Fritzing so that folks can make wiring diagrams, and so internally as well, so we can make these wiring diagrams. Cool.
So you're writing down all this here. Okay. And one of the things I did not note here, I should have explained it more, is the multiple pins that are going to have to be shared between the ground connection, because there's only one ground connection on there. Right. And maybe we need to do a video of how to actually make, I call it like a squid. It's like one connection that's running out, and it like splits into like 4 different cables. Maybe it'll be a topic on Colin's notes.
That's a good idea. We can suggest some.
But that's the only difficult part about that is sharing grounds and the power VHI. Okay. Everything else is pretty self-explanatory, except the measuring of all of the wires to make sure it's all nice and tidy. Yeah. So it's not like you can't even close the lid because of all the wires.
It's one of those things when you're
you definitely have to cut things down.
Cool. Okay. All right, let's move on to the 3D printing part. Got some
3D
supports.
printing, here are all of the individual parts listed.
Good.
I should have put that the legs, you need 6 of them per section, and then obviously 3 feet.
I'm sure somebody's gonna like make really long ones.
You could attach to like a tree or something. Slicing the parts, here are some of the settings that I used. The most notable here are for the supports. You are going to have to print this with supports or like breakaway material. There was no way to avoid it just because of the way the mounting walls and the snap together fit parts are all on the bottom of the body. And here's just some of them. We in the previous layer or previous 3 Hangouts, we went in depth in all of the support materials and actually did some live support material removal.
Are these auto-generated or did you place them manually?
So these are all auto-generated by Cura. And this is just some of the settings that I'm using. The most important for ensuring that any support material comes off nice and easy is the extrusion width. Lower that to 0.2. And with standard nozzle sizes, you're usually printing walls and perimeters at 0.38, 0.4. So this will make it like half the size. You don't want it to be the same thickness as the actual walls. That'll just make it so much easier to remove. The support density, I don't know why the defaults are always like 20%.
That's super
You do
dense.
not need that much density.
It depends on the scaling of your part, though. So if you have a giant part, 20 is like not a lot, right? I think that's what's going on there.
I think so.
Yeah, so it depends on your scale. This is a scale, down, so.
Although I've printed huge things with just 4% density.
Yeah. Maybe the parameter got updated when we updated Cura.
I don't know. But at any rate, most supports that you need on 3D parts don't need to be so dense. That's what makes it so hard. You'll cut yourself. You'll break your part.
What's great is you have here like a nice GIF or GIF. I say GIF, hard G. It's it gives you a good reference visually to see, like you're stepping through the layers and you can see the density, so you can kind of gauge if you're using Cura's process slicer, for example, you can kind of just gauge what the infill percentage is going to be.
Yeah, the second most important thing about this that allows the low density infill to work is we have a brim completely around all of the supports, so it is held onto that bed plate very nice. And then second or third, I guess, would be the support Z height. So that is how the distance between your actual layers and the support material.
Right.
It's usually like the same as whatever your layer height is, and it should not be. It should have a tiny little bit of a gap. Here we're using 0.21, and this is for the Cruelty printers. I tried that on the Ultimakers, and the gap was just too much.
Oh.
So the defaults are like on Ultimakers. So you definitely have to test it with your printer and slicer. But 0.21 seems to work pretty well for the Cruelties, or Crealities. Yeah. Interface supports, I left that on, along with a support roof. Turn that on as well. That's what's going to create the separation between where the supports and your actual part is. The patterns for this, zigzag, I found to be the most reliable in terms of removing without damaging anything. Okay. So zigzag for the support pattern and the roof pattern. And as I said earlier, the build plate adhesion, make sure brims are on and it's turned, and you have on the inside and the outside brims turned out. That's what will allow the supports to have its own brim. Otherwise, it's so thin it won't stick, or will have a difficult time sticking to your bed. Yep.
To remove the supports, you can use some flush diagonal.
I should probably link those.
Sure.
Yeah, it's the flat Haku pliers that we have in the store.
I can pull that up if you want to do a link. Take a break to link real quick or something.
Let's see.
Like try something out. Like we're doing slicing chats. So we just type in pliers, and it's the precision flat pliers from Haku. These are great. These work well with your Haku flush diagonal snips as well.
I would recommend both. One to help pry them off, and then the flush cutters for all of the brims to get all of them off the edges. Let's keep posting links here.
I'm lost in tabs. Where am I? Sorry.
All right, moving on to assembly, or no, code.
I'm lost, man. Sorry. I'm gonna go back. Kill the thing. My
Go
tab
ahead and
disappeared.
jump into installing CircuitPython for ItsyBitsy.
Right.
This is a mirrored page. You should see
It is,
this
yeah.
on any of the pages or projects that require installation of ItsyBitsy. It'll just walk you through to updating the UF2, make sure you're on the most current updated firmware, and then how your library structure should look. Get in the USB to boot or to load.
Yeah. So this it thoroughly covers installing CircuitPython. So cool. All the learn guides have mirrored pages like this so that folks know, hey, here's how you install the latest version of CircuitPython.
Yep.
All right, for the code page, you can download the code off of GitHub, and this is going to walk you through. It's making sure that you have upgraded CircuitPython, the first part of it, and just like a visual way to check that you are indeed in the latest version of CircuitPython. You can check the boot out.txt file to make sure that it says it's the board and all that stuff. All right. So these are the libraries that you'll need for this project. It's got the NeoPixel library, Servo kit, and the PCA 9685, which is like a driver.
Servo driver.
Yeah, Servo driver. So you can check this out. Here are all of the libraries that you can add there. It's just a screenshot of what your drive looks like. So once CircuitPython is installed, plug it into a good USB cable that has data, and it shows up like a flash drive. So that's where all the code and library files go. Yeah, cool. And that's kind of it, really.
Actual code right here. You can kind of.
Here you go. So
I can't read this, so.
I'll
But it's
try to
nicely
read it.
commented.
Yeah, I'll try to read it for you. Yeah, so a couple of libraries. It is using the LED animation library that makes a lot of the animations easy to work with. You can make sparkles and comets and stuff. This one's using Sparkle Pulse and Comet. And it's also using the animation sequence, which allows you to animate multiple animations together. The pins are set up here. So for the pixel, the NeoPixel is on D5, A2, and you can switch these out if you want. And if you have more pixels or less pixels, you can update this 12 as well. Yeah, what else that's really it. The brightness here is set up. It's like 0.6. You could make it more if you want. You can go all the way up to 1, which is 100%. All right. So here it's initializing the servo, and here we're setting up some of the things, the animations. You can change these out if you'd like. And then if you want like more position, I guess you could change this 90 to like 180 if you want, and see if that works. But play around with it. All the random stuff is set up here. Yeah, and it's all commented. So shout out to Phil B for commenting it out.
Excellent life code that he brings.
Code, yeah. Yeah, there's some. Is there some floats going on? No, some ABS. You got some random uniform going on. You got a fraction, elapsed and duration. Yes, yes. So check it out if you have something similar that you want to do. This is a great little piece of code to kind of reference or reuse as you like. So check it out. Cool. Well done, Phil.
One of the things I forgot to mention for the 3D printing part, on Thingiverse, it's not listing the project, so you can get to it directly right there. I posted the link.
Yeah.
Or if you just want the Fusion 360 file, you can grab that as well.
Yeah.
But this will be where the STLs, for the ready-to-go STLs.
There you go. There you go.
Just got to generate your supports.
Cool. Okay. And then the Fusion share link is somewhere, you said?
Yep, in the exact same page, like the button above that. If you want to do the little explosion, take a look at that.
Oh, cool. Yeah, so this link gives you like a...
It gives you like an exploited view of what all the parts are.
An online 3D viewer, so you can see the model. And there it is.
Here is that little guy.
Stuff. Where's the explode tool?
I didn't make everything into components, so it'll probably go all crazy. Oh, there you go.
Fine. Not too bad.
Ooh.
Yeah, the main 3 pieces are there. And you know,
See
all the
walls.
sketches and parametric timeline is all there. So there's that servo. This is a great like model to reference. Like if you ever need to make a custom servo attachment, it's always really good to make your 3D printed attachment go over the existing servo horn, because the servo horn has like, it's an injection molded thing. Maybe if you have a resin printer, you could try to print out the splines. Those are the little grooves and
teeth.
stuff, the little teeth that actually press fits. The stock servo horns that are like, I think they're nylon or maybe they're ABS. But in any manner, that's the method that we like to recommend and do whenever we do a Servo project that needs a 3D printed thing. Always make your attachment fit over an existing Servo horn.
There is quite a bit of little geometry that makes it
Sure
go
is,
over,
yeah.
so I would definitely use that again.
Good
There's like some
tolerances here,
grooves that go underneath to like
Isolate.
yeah.
Isolate.
You can see how that is. Quite a bit of prototyping to get that to work and fit.
Yeah. I can't remember what Servo thing I did, but very similar.
I'm pretty sure I used your sketches from that and then had to build on top of that. So we're always doing that ourselves. We grab things that we've done in the past, update it to the specific project that we're working on.
Yep. Sometimes rotations will change the tolerances as well.
Yes, big time.
Cool. Good
Now I
stuff,
continue on over to assembly. This is a nice long page on all of the things you need to do to set everything up. First off is the Lipo charger backpack. There is a little technique on cutting the trace. Before we used to sit there with a hobby knife and like, you know, scrape away, praying that we wouldn't
you didn't cut yourself or damage the trace. I mean, you're supposed to cut the trace, but damage something else.
Then I figured out, oh yeah, you can just take one of the flush snip cutters and then hold on one side of the mounting hole, and then with your other side push down on it, and then just clamp it shut, and that'll completely rip the trace off of that, so you can attach your slide switch.
Yeah, I'll say it a different way. You can use the mounting hole as a way to anchor one of the teeth of the snips. While one of the teeth is like anchored in through the hole, then you can use the other tooth to cut the trace. That gives it that extra support when you're using the mounting hole. So really good method.
And this could be used on any number of boards that require a trace to be cut to enable something like STI or something. As long as you have a
mounting hole right next to it. That's the magic here, is the mounting hole is right next to where it needs to be.
Yeah, I'm sure you could figure out some way where you can like put I don't know, something that covers like that one end and just use it as a pivot.
Right.
So it'll
well,
still
it's like
cut
a head
it.
stop, right? It's like stopping your blade. Anyway, very cool method. That's how you cut the trace to get a switch, right?
Yeah.
Yeah.
And moving on from that, once you have everything measured out and your slide switch on there, which you are going to do a lot of dry fitting to figure out what the sizes that you'll need for that.
For the length of the switch.
The length of the switch wires, the ItsyBitsy wires to the Lipo charger. And for that, we're using the silicone coated wires because of its bendability and moldability, so you can like keep it nice and tidy inside of this tiny little body.
Yeah, it's more, you can stress it a lot and it won't snap, which is great.
Oh, and you can solder in it right by and it's not going to melt.
Yeah, that's the main thing. It's super heat resistant. Silicone.
All right, moving on to the Mullix connections for the NeoPixel Ring and the Servo. You can kind of see here how I did one wire for the ground and then split it off. And then the exact same thing with the V high. I have one connection on there and then it splits off to share between the two.
Cool. Yeah.
You can kind of see it there, and using the heat shrink that we have in the store too to seal all those up.
So one is for the NeoPixel Ring and the other one's for the Servo. Both of them use 3 connections, right? Okay. Wonderful. And then this one shows
slide switch. Oh, the Lipo Backpack being connected with the slide switch.
Okay. Yeah. Cool.
All right, once you have your little circuit assembly there, it simply press fits into the bottom of the battery. And there are 3 walls. One of the walls has like a little chamfer that will clip onto the wall. So you want to insert it into that wall first, insert it at an angle, and then snap fit it in, and make sure that the Bluetooth module is facing out like so. Yeah, USB port. There's a little cutout here you can't see, but there's a USB cutout there, and that's where you orient it. It's kind of difficult to mount a board with no mounting holes, so this is one of the ways we like to do it, where we have like an end stop here and these 2 little things there. And then there's some underneath it. There's some, I think there might be some standoff bits that elevate the board. So that's a good thing to reference if you ever want to do something similar. Sorry about the lawn maintenance. Sorry, guys. Oh, you can hear it? It's audible. Yeah, they usually come on after the show or Thursdays.
Yep. We're lucky today.
Cool. And, okay, so after that...
Yeah, once you install the PCB, we got another one to do. So this one does have a mounting hole, and hey, you can screw it into the side wall there.
Mm-hmm.
Cool. And that's where that one screw is.
Yep.
Nice. Any orientation ways?
There's only one.
There's only one orientation?
So you have a little wall, again, that does the elevation for you because it is a tapered wall for his body there.
Yeah. Cool.
So that gets inserted there. Not too difficult to get the screwdriver in there.
Okay.
And then after that, the slide switch press fits between those 3 walls.
Mm-hmm. You can insert it at an angle as well, so that the actuator pokes through the opening first, and then you can just slap it down.
You might have some wiggability with the tolerances here. So the 2 metal tabs on the side of the slide switch are able to be pulled apart, gently be pulled apart a little bit, so you can increase that so it can hold on when you're turning your circuit on and off.
Yep.
So I'm just using like one of the wedging tools, not wedging tools, the what's it called? Sputter? Not sputter.
Spudger.
Spudger tools to sort of move those 2 tabs out.
Right. Flare them out. Cool.
Yep.
Here we go.
On to the servo cables. You just want to shorten that up because the included cable is kind of long, and like we were saying earlier, you do have this long, it almost feels like jumper cables, the length of it.
Cool. Just tell PT, yes, we are hosting tonight.
Yeah. Yes.
Yes, we
will mention that later too. That
yeah.
For show and tell, we'll be hosting.
Yeah.
Okay, moving on to mounting the servo. The wires go through that little hole that is on the bottom of the wall there, pass that through, and then it press fits between all the walls there. You can kind of see where the cutout for the wire is on the vertical walls. And then the included screws, I think it comes with like 3 or 4 screws. It's going to be the pointy one with that extended like head.
Yeah, it's a built-in
washer. Built-in washer on it. And that's what's holding it onto that top portion of the wall there.
Sweet.
Kind of difficult to see, but there is a wall that the one of the tabs lines up with the hole there.
Yeah. Cool. All right.
The Lipo battery, it is the JST extension that's going to be needed to reach to the Lipo Backpack. Not by much though. It's just a little wire.
Yeah.
Or it needs to be a little wire because it comes as 100 millimeter long, so.
Yeah. For advanced makers, I suppose you can solder to the pads. We're not supposed to tell you that.
No.
So don't do that.
Because then how are you going to take that out? That's the whole reason why we have all these.
Oh, I see what you're saying.
Because it's going through the body.
Yeah.
You have to unsolder it to disassemble it.
Okay, so don't do what I said. I told you not to do it, so there you go. All right. Well done.
After that is connected, I used a tweezer here, you can see, to align the JST ports and just plug that guy in. And then you just plug in the battery on the other side. Setting up the NeoPixel Ring, we're using another set of the female Molex 3-pin connectors and just measure it so it the length is just long enough to reach to the ItsyBitsy board.
Okay. And then it gets
the 16 NeoPixel Ring snaps right on top of the servo, as you see here. The size, the inner diameter is big enough to snap in at an angle right onto the servo, right beneath the horn. So it's out of the way, nothing is rotating with it, so there's no wires that are like getting twisted or rotated. It's just the head.
Yeah, the only thing that's moving is the head.
And that's the main reason why I didn't want to attach a matrix or something like that onto his eye, because I didn't want to have the head rotate and then it spin and kill itself, Yeah. So the head is just completely separate from any components.
And it's really well done. With my version, it definitely has problems.
Yeah,
with
we can spin around.
Yep. Well done.
All right, everything is then plugged in, tidied up, moved around along the inside of the walls, so you can have a nice space when you're closing up the lid.
Yeah, at this point you can decide whether you want to trim those wires or not, but having some
will definitely want to.
What do you want to call it? Having some slack is good too, because then it gives you room to work with and to figure it out.
Yeah, keep that in mind, the slack.
Slack is good.
And then moving on to the servo horn, like you were saying before, that snaps onto the included horn, and then with the included screw, and that just attaches on top of that, like so.
Yep, it's threaded, so it works well.
Then moving on to the leg assembly, these pieces snap together, and depending on your tolerance, they're either going to be loose or they're going to be a very nice like tightness like this. I really wish they all came out like this because you can really mold them.
They feel like the Hobby Creek helping hands from Hobby Creek. They feel like that.
Yeah. This was printed on the Ultimaker, and it did a really good job with the tolerances. On the Acrylic, it's pretty loose.
Yep.
You do have the ability to sort of keep it if you like bring it out a little bit like that.
Yeah.
That'll like lock it.
Right. Because the ball socket joint is kind of like flaring out a bit with these reliefs here. These little hole reliefs give it that grip.
Yeah, it's so cool when these lock in and then you snap them back in like that.
Pretty cool. Oh, nice.
Move again.
Nice snap.
But I really wish they were like these with the tight tolerances.
Don't touch me.
And moving on to get all those is what is it?
You snap them on, and then the base here, the base bottom cover has sockets there.
Yep,
so
you connect those two
limbs.
Yeah, so like I was saying before, six segments will make one leg section, and you just need 3 of those. Okay. The bottom lid, after all that is assembled, it just snaps to the body.
No wrong way to do it.
No, no wrong way. Yeah.
Symmetrical.
The only thing you can't adjust like when you position the head which way is like looking out. You know, that's the only thing. But again, that's just rotating the head on the servo horn.
Yeah.
Moving on to the diffuser eye, we're just using translucent filament so you can see the LED shining through.
No glue, just press.
Yeah, just press fits right in. Yeah. You actually probably want to do this after you align the head onto the little spokes on the horn because it'll make it more difficult to see where you are.
Maybe paint it first, yeah. Order-wise, I think folks will know. Like I need to paint it and then add the eye.
Yeah.
It's just a little thing.
And after that, you, like I was just saying, you align these little pegs that are on the inside of the head to the spokes on that horn.
Yeah, those are little end stops so that the I'm pretty sure like a spokes are grabs right onto those spokes so that it's locks onto it really.
So it doesn't just spin freely without it moving the head.
Yeah. So these spokes here, like these little frames, the little plus sign, the guards or whatever you want to call them.
Yep.
That's what snaps into it. Cool. All right, and then you test it out. Here's the paint. Here's
We are using what is that paint? Craft.
Click on it.
It's like at Walmart.
Craft Smart.
Michael's, Joann's.
Paint.
I think it was like
it's called Espresso.
$3, $2. It's really inexpensive and it looks really good on this.
Is it Espresso?
It's espresso. Okay, the color.
Yeah, it's like a coffee bronze.
And it has this nice little shine. Looks like the bronze you were saying.
Shiny, metallic. And then the metal. Add that to your shoulder. Put it on your kid. Or yourself.
One thing on the painting, I did print 2 heads just so that I could test painting it, see how to get the clean edges. I didn't use any tape. I just practiced.
It's really good. It's very, very good.
Just practice getting the edges right.
And, the kiddo has his Link costume from last year.
Yeah, so the Link there's like a new Link costume coming out in July.
Ooh.
I was like, why is it gonna take? It must be the part shortage or something. But,
cool.
And I didn't even put down not only his head but all of his feet are painted.
Painted the little trim.
I did reference just type in Guardian Terraco for the patterns on how to paint these. Nice, fun, relaxing painting all of these sections. And then if you look at the actual game character, there are like these little details, like these swirls down here. I just ran out of time.
Yeah.
You could definitely just paint those in. And some like nice splotchiness on there to recreate that nice little rusted metallic look.
I like your version. He's simplified, more cute.
And there you go. A Terraco that you can put right on your shoulder as a companion. Yeah. Super, super cute. And Gavin is downstairs counting down to when he can finally take him home.
He's home right now. All right. Cool. Well, check it out. We got the learn guide. It's published.
Yep, I've been posting all the links for that if you guys want to download the STLs, print one out, edit. If you want to make him bigger, fit more components inside him. There's a ton of expandability.
Cool. All right. Well done.
Yay. So next robot is up.
Yeah,
probably
we'll
be
see.
a Star Wars one.
Yeah, I was thinking DB1, but we'll see. From Fallen Order.
Fallen
Jedi.
Order, yeah.
We'll
That's
see.
a really cool one with
Yeah,
the
he's pretty
legs
cool,
and
man.
everything.
A lot of servos, like 8 servos.
Yeah.
It's crazy.
All right. So let's go ahead and jump into this week's What Are We Prototyping?
Yay, what are we prototyping? Here's the correct slide.
Yeah.
Yeah, so this week we have a square pixel display. Yeah. So I showed you folks the 16 by 16 last week. Lamar wanted more pixels. She said that's not enough. We need more pixels, bigger. So we have a 32 by 32 matrix with a 3D printed frame, and this is black LED acrylic. Now I have it turned off because I forgot to plug it in, but also it's a good way to show you the magic of what is black LED acrylic. Now you look at black LED acrylic, and maybe it's not apparent, but this stuff isn't opaque. You can't see through it. So how is it that when you turn light through it, it becomes opaque? That's a, whoops, I forgot
is
to
that?
remove that one. That's from Doom. Sorry. That's Mario and Luigi, and I know, right? Like the first thing you saw was like these.
Continue with Luigi.
Yeah, that's Nyan Cat. But anyway, this is a 32 by 32 matrix. These are not NeoPixels. These are just RGB LEDs, and that's Sonic, right? So yeah, the black LED acrylic is this really special material that, like I said, it is not transparent until you have light through it. Like it is transparent, but not really that transparent. So here it is. Right? And we have this video here that we did a little bit ago. Let me show you this. Like folks think this is just regular acrylic, but it really is designed for light. Now, if you look at some other acrylic that's transparent, it has like a little bit of a grayness to it. Where is it? Here it is. It actually is not. So this is black LED acrylic, a sample of it, doing its thing. The magic comes out when you have light behind it. And then regular kind of black acrylic just is see-through. It doesn't have any real kind of magic light properties. So when you look, there it is side by side. Yeah, it's quite different. So it's not just your run-of-the-mill black acrylic. I hope I explained that well.
You can kind of visually see what's going on.
So here's a giant piece of it. Adafruit loves it so much that we stock it. It's in stock right now, so if folks want to pick this stuff up, get it before the part shortage gets to that. So it's like $10 for a 12 by 12 sheet. So this right here is only like half of that, so that's cool. So I got this frame here. That's the black LED acrylic. This is one of the frame pieces with these legs, and then the actual PCB. So this is a 3D printed grid that I designed, right? It's only about 6 millimeters tall, and then this is the bare PCB. So the 32 by 32 has a injection molded ABS frame. You can just remove the screws to show the bare PCB, because that is how this works. You see the grid, it has to encompass, has to cover all of the LEDs so that they do not leak into themselves. That's what achieves this effect. That grid really has to go beyond the light source. And with the stock grid, if I were to just put this over, it would kind of look like that, which doesn't work. So I had to remove the stock frame and grid. So that's how this is working. So when it comes to what are you powering it with, I got this beefy 5 volt, 10 amp power supply that we stock as well. And so this here this extra frame here has the NeoPixel grid press fit into it. And on the back here we can see, well, what's powering it, right? So we got our power cable, right? This is cool. This is the Feather RP2040. We're gonna swap that out for a Feather RP2040 once I can get my hands on some more hardware, but this is what's adapting this Hub 75 connector to work. So this is the RGB Matrix feather wing. And both of these feathers are on a feather wing doubler. And then I have these standoffs that secure it to the main frame. But yeah, this is how you're able to set this up here. You have this extra cable and your power cable here. I have this extra switch here, which is really nice if you want to be able to quickly turn this off without disconnecting it. These chunky switches these chunky switches are great. They're just they're for a 2.1 barrel jack, so you can just kind of add that to your existing power supply, and now you have this nice chunky switch that you can turn it on and off. So yeah, very excited about this one. It's running Matrix Animation Player that JP and Melissa worked on. So I'm just assembling here to show folks how it all press fits together. There's just 3 of those pieces, and then Gribblies. Come on, focus.
Focus.
What is going on? There you go. And then where's Party Parrot? There's Party Parrot. So yeah, black LED acrylic, 32 by 32, RGB Matrix feather wing. That's what this is going to be. And this is all CircuitPython running Display I/O, and I forget what other, the Matrix Portal library. So all that together to make these animated sprites.
We have a question on how to make the graphics on these matrices. I'm linking to Phil B's guide, animated
JP's
GIFs.
Guide. JP's guide.
Oh,
yeah.
I'll post both. So here's one from Phil B, and then JP has one. Where is it?
I'm trying to pull it out too. Too many tabs.
Is it the LED matrix display for bitmap, pixel art, and animation?
No. Wait.
This might be
yes,
it.
that's the one. That's
And
totally the one.
Here is another. This is on Twitch. Ben Wood Live. Here are 2 learn guides you can look through on it. JP's explains how to actually set up the sprite and the applications used, and then how to use that to make the individual frames, the BMPs.
We might have to restart the show, right? The computer's like locked up, shut out, whatever.
Still going.
Yeah, I'm really struggling here. All right, cool. So here's the Learn Guide. So this works with the Matrix Portal library, but you can use the RGB Matrix Feather Wing and a feather with this code base. So that's how I have this working. You just have to change a little bit of the library so that it works with the pinouts particular to whatever board you're using. I'll cover all that in the Learn Guide for this because it's not quite, it's not explicitly laid out for you. So here under the Sprite Sheet Animation, this walks you through what is an animation, kind of the fundamentals of animating, and then it goes into like actually creating a sprite sheet animation, which is this software called Sprite. I used it. JP used it as well. It just lets you take an image sequence, so a bunch of JPEGs or PNGs or GIFs, and it allows you to create a sheet, a single bitmap that looks like this. So you see how long that bitmap is? Well, the code is looking for bitmaps that are that long, and it's saying, hey, cycle through these, and it's doing a tile grid of whatever X and Y you have set up. So for this one, it's a 32 by 64. So I just had to make my artwork 32 by 32, crop it, and export it out as a strip here, like this. And it's all documented here. It's a good piece of software to do it. I don't know how to do this in Photoshop.
I was doing this in Photoshop, and it was way more complicated than it needed to be.
It is, because this is automated. Like you just give it the folder of a bunch of images, say that it's an image sequence, and then tell it, I want a strip. And then it gives you this. And we have some demos as well. So if you look at the code here, JP gives you some of them that he made. So if you just want to get it up and running, you can just copy this whole thing and throw it up there. Yeah. And I think you can watch one of JP's streams where he does a deep dive on the code and creating the bitmaps too. So I'm just kind of piggybacking all of his hard work there. I made a frame, blacker than the acrylic.
We got John Story asking, is this going to be a kit soon?
Yeah, maybe we can make
Next
it a
week?
kit or something. It'll be a learn guide for sure. And the cool thing about this display, unlike the $100 16 by 16 NeoPixel display, we stock it. We sell this for only $39. And a little birdie told me that we might be able to get this price down. So don't maybe buy it yet. I don't know. Buy it now. I don't know.
If you want to support Adafruit,
Please support us so we can make this price lower.
Yeah, and this was actually questioned by Mr. Certainly Bruce, was asking for the 32 by 32. If we stock it, yes, it is right here.
If you're gonna get this, make sure that the pitch is 6 millimeters. We do have different 32 by 32s. I can't get this grid any smaller, like in terms of like the pixel spacing. I can't get it any smaller. 6 millimeters is the cutoff point. That's like as small as I can get it. And if you get this like from back there, you almost can't. That's the 16 by 16, by the way. And that one, you can just barely make out the pixels. So if I put this one over there, you don't even see the pixels, at least in the webcam. But if you like the 16 by 16 one, I did release it on Thingiverse. So if folks want to make that, they can. Where the heck is it? I don't remember. I might have lost it. Yeah, I lost it in the, I'll bring it back up though. It's in the description of this YouTube video. You can pull that. You can search the Adafruit blog as well. I made a blog post for it. But yeah, this is the 16 by 16 NeoPixel version. Lamar thought the 32 by 32 one would be a better learn guide, so I just released this as a non-learn guide, but the files are there and there's some photos to show how kind of the assembly is. Very, very similar. It's just these are NeoPixels and they cost a lot. Now there was a matrix that I found on Amazon that was $20 and Lamar investigated. It turns out those pixels might not be grade A. They're like grade C NeoPixels.
The longevity of them.
Yeah, the longevity.
Although these have been running non-stop for several weeks now.
Not weeks, just several days.
Oh.
But, I don't know.
I was going to say several shows.
So if you want to give it a try.
Well, actually, Bruce is saying that they are all gone from Amazon.
Sorry. I must have sold them. I must have did something. Shit. But yeah, that you can use it.
And we have a request by Super Slow if we could turn down the exposure a bit on the product camera so the RGB Matrix animations aren't so blown out, or is it just ridiculously bright?
It's kind of bright. Yeah, I can try to fix that.
And is the grid printable for a smaller pitch? So again, this is 6 millimeter pitch. You can't do 4.
I don't think we could try, but
maybe with a 0.2 mil.
Because like
nozzle.
the whole thing is like once you get even smaller, like at some point like it's just the effect breaks and it might not work because it's too small. But I could just barely get this to work. I know it looks like it's
it's
like
giant,
surely you can make it, but I don't know. And it is kind of giant. Like you kind of need at least a Prusa like i3. So this is 109 or 200 millimeters. Sorry, I'm just out of space here.
Yeah, it's the angle.
You have to put this in first. All right, so that puts in first. The way you cut this is you can do a PDF template like I did and lay it on top, paper template, and then score it and then snap the edges off. Okay. Okay, but this is going to be next week's Learn Guide. We'll talk more about it then. I'm super out of time now.
Yeah, we're out. We had some shop talk stuff. We got some.
We had a lot.
The reason I'm wearing a Tesla shirt, I wanted to show off our solar panels. I know we'll cover that next week. We're going to be hosting Show and Tell later tonight.
Yes, we are.
So definitely tune in for that.
Yeah, we can't wait to see you. You can join in by hanging out in the Discord server. A little bit before the show, we will post a link to StreamYard.
Yeah.
And anybody can come in and say hello. And yeah, that's
definitely show off all the cool projects you guys are working on, your workspace, any artwork that your kids are working on.
Yeah.
Retro tech, all game. Definitely chill out for that. And then right after that, full hour of Lamar Foyle on Ask an Engineer, all the top new products coming out at Adafruit, all the cool projects, and some behind-the-scenes top secret stuff Lamar's been working on. We didn't even get to talk about this guy.
I know, nor did we show the time lapse. Do you want to just really run through it, or
we're done.
We're done, okay.
It's 12, it is lunchtime.
All right, well, thank you guys so much for joining us.
Don't forget to follow us on all the socials. We've been posting a lot of the behind-the-scenes stuff there. Video every single day by Colin Cunningham for Colin's Notes. So,
and some special videos from Phil B. Check those out as well.
All right, looks like one of our batteries have died on the camera, so with that...
Don't forget to make a coincidental day.
See you next week, or later tonight.
Bye.
Bye.
Yay.